Hello everyone. Now I'm going to explain the next phase of the data science process, namely data exploration and data modeling. After data preparation is completed, the collected data must be explored to understand pattern and relationship. Then suitable models are developed to extract useful knowledge and make predictions. In this presentation, we will discuss various visualization techniques used in data exploration and the important steps involved in data modeling. So we are going to see the mind map of data exploration. Data exploration is a process of understanding data before building any model. The objective is to identify patterns, trends, relationships, and unusual observations within the data set. Through exploration, data scientists gain insights about the nature of the data and determine the most suitable analytical techniques. Data exploration serves as a bridge between data preparation and data modeling. Data exploration techniques. Information become much easier to understand when it is presented visually rather than in tables of numbers. Therefore, graphical techniques are widely used during data exploration. Some common visualization techniques include simple graphs, histogram, Sankey diagrams, network graphs. These visualization help us understand distributions, relationship between variables, and data flow patterns. By observing these visual patterns, representations, hidden insights can be discovered quickly. First, we are going to see about bar chart. A bar chart is used to compare value across different category. In the chart, each bar represents a category and the height of the bar indicate the value associated with that category. For example, if the chart represents product sales, taller bars indicated products with higher sale, while shorter bars indicate products with lower sale. Bar charts are useful because they allow quick comparison between categories and make differences easy to identify. Next, we are going to see about line chart. A line chart is commonly used to show trends over time. Each point on a graph represents a value recorded at a specific time, and the points are connected using lines. For example, if monthly sales are plotted on a graph, we can easily observe whether sales are increasing, decreasing, or remaining stable over time. Line charts are particularly useful for analyzing changes and forecasting future trends. Next, we are going to see about distribution graph. A distribution graph helps us understand how data values are spread across a data set. The shape of the distribution provides important information such as central tendency, variation, presence of outliers. For example, if most observations are concentrated around the center, the data may follow a normal distribution. If the observations are spread unevenly, it may indicate skewness or unusual patterns. Studying distribution helps data scientists to choose suitable statistical and machine learning techniques. Next, we are going to see about overlaying. Overlaying means displaying multiple data sets or multiple graphical representations on the same chart. This technique allows direct comparison between different groups of variables. For example, if sales data from two different years are displayed on the same graph, we can easily compare performance between the years. Overlaying helps identify similarities, differences, and trends that may not be visible when viewing datasets separately. Next, we are going to see about brushing and linking. Brushing refers to selecting a subset of data points in one visualization. Linking means that the same selected data points are automatically highlighted in other related visualizations. For example, if a group of customers is selected in a scatter plot, those same customers may be highlighted in a bar chart or map. This interactive exploration technique helps analysts investigate relationships across multiple visualizations and gain deeper insights. Next, we are going to see about the next phase, data modeling. After understanding the data through exploration, the next step is data modeling. Data modeling involves building mathematical or machine learning model that can identify patterns and make predictions. The goal of data modeling is to convert raw data into useful knowledge that can support decision making. Examples include prediction models, classification models, clustering models, and recommendation systems. Building a model is an iterative process. This means the model is repeatedly improved until satisfactory results are achieved. The modeling approach depends on whether we use traditional statistical technique or modern machine learning methods. The process generally consists of three main steps: selection of a suitable modeling techniques and variables, execution of the model, diagnosis and comparison of model performance. These steps ensures that the final model is both accurate and reliable. So, model and variable selection. This slide discusses important consideration when selecting a model. First, we must determine whether the model will be deployed in a real production environment. If deployment is required, the model should be easy to implement and integrate into existing system. Second, we should consider maintenance requirements. Some models may become outdated as new data become available and require frequent update. Third, we must consider explainability. In domains such as healthcare, finance, and education, stakeholders often need to understand how predictions are generated. Therefore, selecting an appropriate model involves balancing accuracy, maintainability, and interpretability. Next, we are going to see about model execution. Once a model has been selected, the next step is model execution. During execution, the prepared data set is provided as input to the selected algorithm. The algorithm processes the data, learns pattern, and generate predictions or classification. This stage converts theoretical model design into practical results that can be evaluated and improved. So this is just example of a model execution. During execution, the model analyzes relationship among variable and adjusts internal parameters to improve performance. For example, in a student performance prediction model, factors such as attendance, assignment marks, and test scores may be used as input. The model learns from historical data and predict future student performance. This process enables organization to make data-driven decisions. So next we are see about model execution and evaluation. After execution, the model performance must be evaluated. Evaluation helps determine how accurately the model performs on unseen data. Common evaluation measures include accuracy, precision, recall, error rate. Different models may be compared using these metrics and the best performing model is selected. This evaluation step is essential because a model that performs well on training data may not always performs well on new data. So in this presentation we were discussing the data exploration techniques as well as data modeling process. Thank you for your attention.